Hi, we introduced the paper Cross-Guided Optimization of Radiance Spheres with Multiple Image Super Resolution for High-Resolution Novel Synthesis. Among the methods for novel synthesis, Radiance Spheres is capable of novel synthesis for an arbitrary resolution as it learns a continuous volumetric representation. However, Radiance Spheres rely heavily on the spectral characteristics of coordinate-based networks. Thus, there is a limit to improving the performance of high-resolution novel synthesis. We simply think that it will be solved using single-image super-resolution. However, single-image super-resolution has multiple solutions. Therefore, we propose a novel framework using cross-guided optimization of the single-image super-resolution and radiance fields. Our key idea is as follows. Radiance fields have the ability to find scene geometry and optimize 5D dimension functions simultaneously. Still, radiance fields have a low ability to perform super resolution, and even if they synthesize high-resolution images, they only depend on the characteristic of continuous scene representation. On the other hand, single-image super-resolution generally specialized in learning the inverse function of image degradation. Therefore, single-image super-resolution could be beneficial to high-resolution novel synthesis by super-resolving train view images. However, single-image super-resolution is an ill-posed problem for which multiple solutions exist and multi-view consistency cannot be maintained when multiple images are processed separately. We propose a novel framework for cross-guided optimization that simultaneously improves both performances by performing multiple image super resolution and radiance fields optimization complementary to each other. In our framework, our model performs train view synthesis during the radiance fields optimization process. Then, we generate voxel-based uncertainty fields to obtain uncertainty maps to find reliable regions in rendered RGB images. Repeating the update process makes train view images have multiple consistency and high frequency details simultaneously. We propose an SR update module that aims to derive the SR output of higher quality than single image SR output. SR update module gets the information about the reliable region in rendered RGB map using rendered uncertainty map. To train SR update module, we used two large-scale novel synthesis datasets, RTMV and blended MVS dataset. We made the rendered train view RGB images, uncertainty maps, and paired low-resolution and high-resolution images as a training dataset for SR update module. Our framework receives guidance from the train view synthesis of radiance fields and performs updating super resolution results using SR update module. Although RGB images reflecting the scene geometry of multiple images can be obtained from train view synthesis, train view images for optimizing radiance fields are predicted as outputs, not ground truth. Thus, synthesized train view outputs cannot be trusted completely. Therefore, we generate the uncertainty map through the following inference. If the integrated error of pixels rendered from rays passing through a certain 3D point is high, the RGB values sampled at that point have higher uncertainty. Based on this, we make the uncertainty map by integrating the rendered errors. We qualitatively compared the uncertainty map and the error map with trained RGB and ground truth for various views in the LEGO scene of the synthetic nerve dataset. As shown in the right figure, high errors occur in the high activated uncertainty region. We compared the super-resolution and high-resolution novel synthesis results with various super-resolution methods. We use PSNR, SSIM, and LPIPS as evaluation metrics. Our method has the highest performance in the synthetic nerve dataset and all three metrics. We also perform ablation studies to prove the positive effect of rendered RGB images, uncertainty, and the number of updates. In qualitative comparison of high-resolution novel synthesis, our models generate accurate text images for novel views and synthesize clear textures. High-resolution novel synthesis performance also serves as indirect proof of improved view consistency. In super-resolution results, our models generate a perfect texture and a small repeating patterns. Sequential results for the same scene demonstrate visually high multi-view consistency. This is the end of my presentation. Thank you.